Hi, my name is Danielle Jensen, and I am the math department chair here at Menlo School. I've taught at Menlo since 2003, and I'm excited to tell you about our program. Okay, so most adults watching this probably experience math class similar to how I experience it, as a lecture from the teacher, followed by completing several exercises from a textbook, looking something like this. Maybe this looks familiar to you. Maybe it looks a little intimidating, but well, exercises certainly have their place. We at Menlo don't believe they further a student's learning, nor do they promote creativity and problem solving. So at Menlo, we seek to do things a little differently. Our classrooms are super lively as we introduce topics through problems versus exercises. To me, a math problem and a math exercise are different. A problem is a task that a student can read, process what is being asked, and maybe get started, but they don't know exactly what to do or where this is necessarily headed. They have to try things, they have to hypothesize, make conjectures, and engage in mathematical discourse with one another, and possibly come to the conclusion that, wait, the path they're going down isn't working, time to try something new. Whereas an exercise is a task that a student reads and knows exactly what to do. Usually it's mimicking what the teacher just did. And it's meant just to exercise a little muscle memory on a narrowly focused skill. And again, they do have their place at times, but we believe that problems are what engage kids' curiosity and promote more sticky learning experiences. And moreover, today, more than ever, we feel like a strong math education needs to emphasize problem-solving skills, data analysis, flexible thinking, and being comfortable with the unfamiliar. Okay, so right now I'd like to show you a topic that is taught all across the country in high schools, and explain to you the difference between engaging with this through exercises versus problems. All right, when I was in high school, all right, here we go. When I was in high school, I learned about triangle congruence. And kids can quickly search on Google and come up with the following, as I did with a quick search. And there are 5 ways to declare that triangles are congruent. And certainly I could write this on the board and have kids copy it, but kids do not need me to do this. Math education today cannot be just about the transmission of facts. It has to be about helping kids develop deep, enduring understandings, helping them understand why a result is interesting, and helping them have the confidence to assess the validity of a particular idea on their own without me just telling it to them. Okay, so how do we at Menlo engage kids in a discussion of this? My teacher in high school, as I mentioned before, gave me lots of facts and answers. Here at Menlo, we see it as our job to ask instead interesting questions. So let's see what an interesting question about triangle congruence would be. Well, this is something we would do. Okay, so we can ask questions, and not only, by the way, not only is it important to ask the questions, we also want to set students up for success and set them up with materials that might help them explore this. So here are some questions. Do you think side, 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 meaning given 3 fixed side lengths, is this enough information to declare a unique triangle? Well, what about side, 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 side? 4 fixed side lengths of a quadrilateral. Is this enough to declare a unique quadrilateral? So what we do in our AGA, which is our Analytic Geometry and Algebra freshman courses, is we put straws on a string and ask kids what they notice. So if we put 3 straws on a string here and tie a knot, you get a really rigid figure. And whereas if we did this with 4 straws, not so much. So a little less rigid. And in fact, I can, unlike the triangle, I can kind of set the angles to what I want and get a different type of quadrilateral. This is also true if I have 5 side lengths or in my 5 straws here. And so with the triangle, students realize, wait a second, once I tied the knot, I can't do anything. I got to make no decisions here. I couldn't decide the angles, it was just set. This must mean that my triangle has to match anyone else's with these same straw lengths. And so it is not just important for a teacher to teach a student a mathematical result, is also important for the teacher to have students see why the result is interesting. This is interesting because it is only true for triangles. As we saw before, it is not true for other figures here. It's what makes triangles special. They are rigid figures. So this type of activity we find creates a sticky and enduring understanding that standing at the board and just giving kids facts and having them take notes does not. Let me give you another interesting question here. Okay, so if I asked everyone in the class to draw a triangle with the following information, would everyone's triangle be the same? I like this question too, because it kind of even how to set it up is a little bit of a puzzle that students have to kind of figure out. So some students will start by drawing side length BC, but then they hopefully soon realize that, well, how am I going to on BC draw angle A? So then they'll, which is an important lesson to realize, all right, this path isn't working for me. Let me switch gears here. And eventually everyone draws AB with length 10. And now we'll draw in our angle. Okay, so now in terms of finding, now the last piece of information that I need is I need to put point C so that BC is 8 units long. And when they do this, they realize, there are infinitely many places I could put point C so that it's 8 units from B. And those happen to, all those infinite points would make a circle here. However, we told them that BC had to be, not only do I have to satisfy the BC being 8 units, but I also have to have it so that BC is on that ray coming from point A. So in doing this, students come to the conclusion, oh, there's not infinitely many triangles here, but there isn't just one. There are actually 2 places I could put C. So much to their delight, there are 2 possible triangles. So this is not a case where I would only I could only declare there is one unique triangle with this given information. Again, this method of instruction is very different than just standing at the board and telling kids facts that, frankly, they could just look up on their phone. All right, let's switch gears here a little bit. I am also the chair of the computer science department, which has 4 course offerings. So let me just tell you a little bit about these. Our first course is CS1, the Introduction to Computer Science, and it follows the Harvard CS50 curriculum. And students are introduced to the concepts of programming. They are taught to think algorithmically and solve problems collaboratively and efficiently. It's designed with low floor and high ceiling tasks that it's meant to be accessible for students who have no experience with coding, but also to be engaging and interesting for students with experience in coding. Another course we have is app design and development, which students can take after they've taken any of our other CS courses. And it's for students learn how to build apps that solve real problems for real people. And they build fundamental app development skills with Swift. It's a year-long course. And then CS2, algorithms and data structures, is equivalent to an AP computer science and more. So by the end of it, students will be able to sit and do well on the AP exam, but again, it goes beyond that. Teaches fundamentals of computer programming using Java programming language. And students leave with a solid understanding of the programming and design process. Finally, the last course we offer, which is great because students can take it multiple years, is advanced topics in computer science. And this offers students the opportunity to practice with new programming languages from Scheme, Python, C, C++, and more. And students collaborate on a variety of ambitious programming projects. And it's great because it's a class that really is driven by the students and their interest in this field. All right, I cannot go without showing you our upper school math course offerings. And when admitted to Menlo, sometime, and hopefully you accept, in April, students will sit around table. Students will come to Menlo and sit for a placement test. And our aim there is to place students in the most appropriately challenging math course that will set them up for success throughout our program. The vast majority of our students are either placed in integrated geometry and algebra or analytic geometry and algebra honors. Of course, if students do qualify to place out of those, that happens as well. But at Menlo, and in many ways, perhaps this is unique to Menlo, but I hope not, but we believe it's not about what you've seen in terms of topics and courses. It's about what you know and what you can do. And so we really are about long-term, deep conceptual understanding of the material. It is not a race just to get to calculus. We really want to make sure our students have a strong understanding of the material and a good problem-solving background. Very proud of the fact that we have 2 statistics classes, as in this day and age, being able, in this age of being able to deal with big data, in this age of data science and machine learning, having exposure to that is very important. And so in those classes, kids do get to work with big data sets and to analyze them. And so I always recommend that if kids can, to take one of those courses. And the nice thing is when students get to the junior and senior year, they have much more flexibility in terms of their schedule. So often our students will take more than one math class. And finally, I'm going to leave you with this. I love this picture because it really showcases the uniqueness and how special Menlo is, in that not only are our students engaged in the classroom and really devoted to learning and their intellectual pursuits, but they're also very well-rounded kids. Sports, arts are incredibly important to them, student government, and they're very supportive of one another. And there's always kids, people who don't know Menlo and they come to the campus, they're always so shocked to see that everyone's always in Menlo gear every day. People just are very proud to be a part of this community and very grateful. Well, thank you for listening, and I hope to see you on campus in the future. Go Menlo!